Hello, Year 5. You are looking lovely today. Look at you. Lovely smiles on your faces. Love what you're wearing. You just look ready and raring for some fantastic maths. I'm obviously joking. I can't see you, but I'm sure you look lovely. We are doing our third lesson on volume today. So I will share my screen with you. And before we start, let's talk about times tables. So I've had a look at Times Table Rockstars, and because this is our last week of learning at home, and next week we're so excited that you're going to be coming back to school, all of you. I've looked back over the whole time that school's been closed and had a look at who's put in the most minutes on Times Table Rockstars for that whole time. So the children at home who've put in the most minutes are Alfie, Finley, Maddie, Harry Fisher and Harry Meredith. Give yourselves a little round of applause. And the children in school who've put in the most minutes. So these are children who've been in school sometimes or all the time. Well done to Ollie, Charlie, Logan T, Logan TG and Evie. So well done you. Now this week, I would like you to focus on the 12 times table. So you can see the 12 times table there, and your garage level on Times Table Rockstars will be set to the 12 times table this week. So if you'd like to do a bit of practice of that now, you can pause the video, you can use the 12 times table on the board to help you, then you could look away and practice, see if you've got your answers right, and spend as long as you'd like to doing that. And then when you've got some time, go on Times Table Rockstars and practice on garage level. Remember, the other levels will include all the other times tables as well. Right, so if you're ready to move on, our learning objective today is to estimate volume. So if you can write your learning objective and today's date in your maths book, that would be fantastic. And I'll just go through the signs of success with you while you do that. So we need to know that volume is a measurement of three-dimensional space. Hopefully you've got an idea of that now after our lessons last week. We're going to again use cubes, but this time to estimate the volume of an object. And you'll see how we'll do that in a little while. We're also going to choose appropriate estimations of volume to match an object. So looking at some different volumes that it could have and thinking which one do we think fits best. And we're also going to use our knowledge of volume to solve problems. So that's the plan for today. We're estimating volume. If you need a bit more time to write your LO and date, then you can pause the video now and press play when you're ready to carry on. If you're happy to carry on, let's keep going. Okay, so for our review part of our lesson today, I've got a true or false question for you. So you need to do a bit of thinking about this one. Mo and Eva are building shapes with cubes. Here's Mo's shape. These are the cubes Mo's used. Very nice. And Eva, we can't see Eva's shape, but she's talking to us about it. Eva said, my shape has a height of 8 cubes, so the volume is greater than Mo's. My shape has a height of 8 cubes, so the volume is greater than Mo's. So I'm looking at Mo's shape here, looking at the fact it's got 4 cubes high. She's saying that her shape is 8 cubes high, so it must have a greater volume than Mo's. Now, you don't need to write anything down, but I'd like you in a moment to pause the video and have a think about what you think. Is that true or is that false? And I wonder if you can give a reason. If you're with somebody, maybe you could explain that to them. Or if you're on your own, just have a little think and then press play again when you're ready for us to talk about it together. Right, let's have a think about that then. So I suppose that it could have been true, but it also could be false. So I kind of think it could have been true. Yes, her shape could have had a greater volume because it could have been 8 cubes tall and then also had a greater volume. But also it could have been false. And this is the reason. Eva, we know her tower was 8 cubes tall, but we don't know how wide or deep it was. So she could have made a tower like this. That could be her shape, 8 cubes high. Now, I'm just going to pause recording, everybody, because the phone is ringing, which means I have a delivery. I'll be right back. Hello everyone. It wasn't a delivery for me at the door this time. It was somebody who'd locked themselves out of their flat and they said, can you please let me in? So I pressed the little button and let them in. Where were we? We were talking about volume. So she said her tower was 8 cubes tall. His is only 4, so she thought hers had a bigger volume. But if we look at this one, if it was just 8 cubes and just 1 deep and 1 wide, then the volume would be 8 cubes. His volume is 24 because even though it's only 4 tall, we've got 4 by 3 by 2, which makes 24 cubes. She also could have made a shape like this, which is 8 cubes high and 2 wide, but only 1 deep. So that would be a volume of 16 cubes, again, smaller than his, okay? So there's lots of other shapes she could have made that were 8 cubes high. So it might be that hers did have a bigger volume, but it didn't have to have a bigger volume. She could have made a shape that had a smaller volume, even though it was taller. Remember, volume is the amount of space that's taken up by that object in total. Okay, so we know that today our learning objective is to estimate volume. So we need to think about what estimate means. So have a little think to yourself about what it means to estimate something and what an estimate is really. So to estimate something, often people say it's like guessing. I would say it's a little bit different to just guessing. You're using your knowledge to make a best guess. So it's not totally guessing, oh, I think the volume is going to be, 27 centimeters cubed. You're using what you know and then applying that to come up with something that is roughly accurate, okay? So why might we sometimes have to estimate the volume of an object? Yesterday, we were looking at shapes like this, where we had cubes marked out for us. Maybe they were built out of 1 centimeter cubes. And that made it quite easy to work out how much space they took up, because if a cube is 1 centimeter by 1 centimeter by 1 centimeter, we know that's 1 centimeter cubed volume. So then I can just add up all the cubes and that tells me the volume. I might have to estimate though, because not all shapes are going to be made up of cubes like this. It would be very convenient if they were, but they're not. So a lot of shapes or liquids or gases that we're trying to find out the volume of, we're not going to be able to handily divide it up into 1 centimeter cubes. Have a look at these shapes down here, okay? If I can't see 1 centimeter cubes, it's going to be tricky for me to work out the volume that way. So sometimes we need to estimate the volume of an object, and we're going to look at some different ways of doing that today. So here's one way. Rosie, I don't know who Rosie is, but she's had a go at estimating the volume of these cubes. And she's used her own, she's had a go at estimating the volume of these shapes, but she's used some cubes to help her do that. So have a look at the pictures of what Rosie's done. So you can imagine she might have used like little multi-link or maybe square shape, cube shaped Lego. Have a look at what she's made. Each of the cubes she's used has a volume of 1 centimeter cubed, okay? And think about how that's going to help her to estimate the volume of those cubes. Okay, so hopefully you can see that the shapes that Rosie's made out of her 1 centimeter cubes kind of match with the shapes that you can see above. So have a little think. I'm sure you can tell which one she thinks is going to help her with each shape, okay? So this one's a cube. I'm going to imagine that she's using it to help her work out the volume of the cube. And then here, this is sort of a pyramid shape made up of 1 centimeter cubes. So I wonder if she's going to use that to help her measure this pyramid. And here, I wonder if this shape here is going to help her find out the volume of this shape here, which is a 1, 2, 3, 4, 5, 6 hexagonal prism. So we've just talked about which one we think would give her the best estimate for each of the shapes. Now, the reason it's an estimate and not exact is you can see, can't you, that these shapes here that she's made aren't going to be exactly like the shapes above, okay? They're going to be roughly a similar shape as long as they're the same size, but it's not going to be a perfect way of working it out, I suppose, except for maybe the cube. So what I would like you to do is have a think about how I would find the volume of the cube. So in fact, I'm going to say you can choose. You can have a choice. It doesn't have to be the cube, says the cube there, but you can choose either the pyramid or the cube or the hexagonal prism. See if you can work out what their volume might be by looking at the cubes that Rosie has used and using that to estimate their volume. So have a little think. Maybe if you're with someone, you could have a chat with them about it, and we'll talk about it. We'll go through how we would do that together in a moment. You can press pause if you want to do that, or if you want to, you can just carry on playing and we'll have a go together. Right, so we'll start with our hexagonal prism because it's the first shape Rosie's made here. And she's made them out of 1 centimetre cubes. So if we count up the cubes that we think we can see there, thinking about any we can't see in the other layers, that will help us have an estimate of the volume of this shape. So here on this kind of layer of her cube shape, she's got 2, 4, 6, 8. And I think she's got the same on this side because she's got 2 by 4. So 8 add 8 gives me 16. And then in the middle here, she's got 4 rows of 3, okay? 4 by 3, which is 12. So I need to do 16, add 12, which is going to give me 28 centimetres cubed. Remember that 3 is going to be floating above the centimetre. Okay, let's have a look at the cube next then. So with the cube, I know that each of the sides are going to be the same length. So we've got 4 by 4 by 4. So 4 times 4 is 16. And then 16 times 4 is 64 centimetres cubed. A little floaty 3 above our centimetres to show it's cubed and not just centimetre 3. And then let's look at the pyramid. So Rosie had made the pyramid out of this shape. So let's look how many cubes she's used. So on the bottom layer, I can see it's 4 by 4 and it's just one layer of cubes there. So 4 times 4 is 16. I'm going to make myself a little note of that so I remember that that layer is 16 with my excellent pen skills using my mouse. The next layer up is 3 by 3, which is only one cube deep. So 3 times 3 is 9. And then I've got a 2 by 2 layer there, which is going to be 4. 2 times 2 is 4. And then on the top, I've got 1 cube. So now I can just add up those layers to find out what the volume is. So it's a bit like using my square numbers, isn't it? And adding those up. So I'm thinking about what order I'm going to add those together in. Well, I know 16 add 4 is 20 using my number bonds. And then 9 add 1 is 10. So my estimated volume is going to be 30 centimetres cubed. Okay, I wonder if your estimated volumes were the same as mine, depending on which one you chose, okay? Now, let's have a go ourselves at doing this independently. So I'm not going to explain to you what to do for this one, and I'd like you to have a go in your books. So this is step 1. Rosie, here she is again. She's using cubes to estimate the volume of a triangular prism. So here's the triangular prism. It's obviously just a picture of it, but you can imagine it's a 3D shape. She's made that shape out of centimetre cubes to see if she can estimate the volume. So 1A, why do you think Rosie stacked her cubes like this? The volume of each cube is 1 centimetre cubed. Work out an estimate for the volume of the triangular prism. So think about that same strategy we talked about. How many cubes on the bottom layer, then the next layer, then the next, and add them together. C, why is the answer only an estimate? And do you think the estimate is more or less than the actual volume? So you have to do a little bit of thinking for yourself and explaining your ideas, but also working out the estimate of the volume of this triangular prism. So press pause, have a go in your maths book, and press play again when you're ready for us to go through those answers. Right, let's have a look together then. Well done, Year 5, for having a go at that one. So 1A said, why do you think Rosie stacked her cubes like this? Now, you might have lots of different answers, so there's not an answer on the board for you. But you might have said that it's because it's roughly the same shape and size as the triangular prism. She's trying to kind of show what the volume would be in a different way. It makes it easier for her to count the cubes. Maybe she's, you know, done different colors to help her count each layer. I don't know what you've written, but hopefully you've thought a bit about it being kind of the same shape and the same size, roughly, okay? B, the volume of each cube is 1 centimetre cubed. Work out an estimate for the volume of the triangular prism. And it says, here it says, show your workings. You might have shown your workings out, or you may not have. But this is just showing one way that you could have done it. So here they've looked at the bottom layer, these green cubes here, and they've gone 10 is 10 by 4, so that's 40 cubes. The next layer up, 1, 2, 3, 4, 5, 6, 7, 8 cubes by 3 cubes. Again, see how your times tables are helping in every part of maths. 8 times 3, 24. And then on the top there are 8 cubes there. So they've added the 8, and they've added those 3 parts together to find 72 centimetres cubed. And what they've used here is they've said volume. It doesn't say volume equals 72 centimetres cubed. They've used, it's like an equal sign. I don't know if I can draw a bigger one for you, with wiggly lines. And that means it's kind of roughly, it's an estimate, yeah? Because it's not going to be exactly 72 centimetres cubed, but we think it's roughly there. Okay, that brings us on to C. Why is the answer only an estimate? Now, you might have written lots of different things for this, but the example answer is it isn't exactly the same shape and size as the triangular prism. So it's not an exact answer of the volume because it's not exactly the same shape and size, but it's roughly. And then D, again, that was your opinion. Do you think the estimate is more or less than the actual volume? So have a look at that shape, have a look at that one and think, do you think it's going to be more than 72 centimetres cubed or less than? Okay, again, that's up to you. Right, we've talked already about one way of estimating the volume of a shape, building it out of centimetre cubes and then finding the volume of that. But sometimes we don't have any centimetre cubes to use, and sometimes we're looking at much larger objects and they're too big for us to build out of centimetre cubes. So sometimes it's helpful to compare an object with another object that we do know the volume of. So let's have a look at this example. So here's box A, and I know that box A has got a volume of 600 centimetres cubed, okay? I don't know the volume of box B, but I can use what I know about the box A and its volume to help me with finding the volume of box B. So I can see here, box A looks like it's roughly the same height as box B. It looks like it's roughly the same depth here as well, but the difference is just the width, okay? Box B is much wider. So I can think about, well, how many of box A do I think I could fit into box B? I'm looking at its width here, and I'm wondering how many of those could I fit? 1, 2, 3, 4, maybe 5. So maybe I could fit 5 lots of box A into box B. Now, if box B is 5 times bigger than box A, I wonder if you can think about how I might work out its volume, how I could estimate its volume. So hopefully you were thinking the same thing as me. I know that box A is 600 centimetres cubed, and I know that box B is roughly 5 times the volume. I can fit roughly 5 of box A in there. So I can multiply box A. Oh, my multiplication sign's gone floating like my 3. I can multiply box A by 5 to find the volume of box B. Now, again, we want to use our smile multiplication to help us with this, because I know what 6 times 5 is. So I must also know what 600 times 5 is. So 6 times 5 and then make it 100 times bigger. Have a go in your head. Okay, shout out to me what you think it is. Oh, I didn't hear you, but I'm sure you've done a great job. So 6 times 5 is 30, and I need to make it 100 times bigger. So my estimated volume is 3,000 centimetres cubed. So we've looked at two different ways of estimating volume. We've thought about building something out of cubes. We've thought about comparing different objects. So in step 2, we're going to be doing a little bit of that. So for 2A, you've got 3 different pictures of objects. One of them's a wardrobe, one of them's a microwave, and one of them's a mug. And it's given you 3 different approximations of their volume. You need to have a look at those approximate volumes and decide which one goes with which. So you could write wardrobe, microwave, mug, and then write which of those 3 you think would go with it. So it's about comparing their size. You know which one's largest, which one's smallest, which one's in the middle. Okay, then for 2B, once you've done 2A, you've got some options. So if you're in class, I'd like you to use some multi-link cubes to estimate the volume of some objects in the classroom. So find an object that you'd like to find the volume of, and then use some cubes to estimate that volume, okay? Just like we kind of looked at in step 1. If you're at home, I imagine you don't have those multi-link cubes to use. So instead, you could estimate the volume of some objects compared to the volumes above. So once you've decided which volume goes with which, you might have a look around your house and see if you can find something that's sort of going to be the same size as a mug, or maybe something that's going to be a similar size to a microwave, or maybe a bit bigger or a bit smaller. And then decide roughly what you think the volume of your shape would be. You could also, if you find something roughly cuboid shaped, and this goes for wherever you are, if you can find something roughly a cuboid, I'm looking around myself and thinking, I'm not sure if I can find something that's a cuboid. But if you can, then you could measure the length, the height and the depth, so those 3 dimensions, with a ruler, and then multiply those together to find the volume. So it's not really an estimate, it's you calculating it, but if you'd like to have a go, you can. So you would multiply the length and the height together, find that answer, and then multiply it by the depth, or whichever way around, okay? So multiply 2 of those measurements by the 3rd one. So you can pause the video, have a go at 2A, which is an answer in your book, and then 2B, have a go at estimating the volume of some different objects, either by using cubes or by comparing them to the volumes you found in 2A, okay? Press play when you're ready to move on to a little bit of problem solving. Right, let's just quickly check our answers for 2A. So you can see that they've been joined up. So the wardrobe, the best kind of approximation of its volume was the largest one there because it's the largest object. So 330,000 centimetres cubed. The microwave, the best approximate volume would be the middle one because it's the kind of the one in between the mug and the wardrobe in terms of size, so 33,000 centimetres cubed. And the mug, 330 centimetres cubed, because it's the smallest object there, and that's the smallest measurement, okay? And on 2B, it depends what you chose. So I can't tell you whether your answers are right or wrong. That it completely depends on what you were estimating. Right, and just to finish off our learning about volume, we're going to look at how we might solve a problem about volume. So let's just read this one and we're going to work it out together, and then you're going to have a go at one for step 3. So Stan, I don't know who Stan is, but Stan's putting boxes on a shelf. Now, looking at the picture, I'm not sure Stan's doing a brilliant job of putting those boxes on the shelf. They look like they might fall off. But we do know that each box has a volume of 300 centimetres cubed, so each box. What is the maximum estimated volume of boxes that can fit on the shelves? What is the maximum estimated volume of boxes that can fit on the shelf? So we need to work out roughly how many boxes could fit on this set of shelves, and then what their volume could be, knowing that one box has a volume of 300 centimetres cubed. I wonder if you could just have a little think about how you might approach solving that problem. What might you do first? What might you think about first? And then what might you do next? So just have a think for a moment. Okay, now I'm thinking the first thing that I might do is have a look and visualize how many boxes I think are going to fit on these shelves. Now, I think that you can fit 3 boxes on each shelf, just looking at this shelf here. So 3 boxes on each shelf, and there are 1, 2, 3, 4 boxes. So 3 boxes on this shelf, 3 on this one, 3 on this one. Oh gosh, that was a brilliant 3 Mrs. Hardy just wrote. And then 3 on the bottom one. So again, I'm using my times tables, always using my times tables. So I've got 4 lots of 3 there, so that's going to give me 12 boxes, okay, 12 boxes. Now, I know that 1 box has a volume of 300 centimetres cubed. I wonder if you can think, how might I work out the approximate volume of all of the boxes on the shelf if I know that one of them has a volume of 300 centimetres cubed and I can fit 12? Okay, I wonder if you're thinking on the same lines as me, year 5. So I'm going to take 300 centimetres cubed and I'm going to multiply that by 12. Again, I can use my SMILE multiplication to help me. I know what 12 times 3 is using my times tables. 12 times 3 is 36. And I'm going to make it 100 times bigger because I'm not doing 12 times 3, I'm doing 12 times 300. So the volume of all of the boxes on my shelf, I think, is going to be 3,600 centimetres cubed. Okay, so what I did was I did a bit of estimating with my eyes. So I visualized what I thought would happen. Then I've used some multiplication to help me work that out. I've thought about the volume of 1 box and multiplied it by the total number of boxes. Okay, so hopefully you can use those skills to help you with this step 3 problem. We've just got 1 problem and it's got 2 parts to the question. So we've got a lovely fridge here and a shopkeeper's estimating the volume of that fridge. He's not sure what the volume is, he wants to know roughly. Now this fridge holds 40 bottles of water. Now I can't see, I don't think I can see all 40 there, but I imagine there's some behind them. The shopkeeper uses cubes to estimate the volume of 1 bottle of water. So he's got 1 bottle of water here and he's using cubes to work out, to estimate its volume, a bit like we did back in step 1. So you've got to estimate the volume of the whole fridge using that information. And then 3B says, does this mean that all fridges have the same volume? So a question for you to think about and write your answer. So first of all, we need to estimate the volume of this fridge. So I would suggest you estimate the volume of 1 bottle of water first. But remember, you might want to do that wiggly equal sign because it's not an exact answer, it's an estimation. And then you can use that to work out what the volume of 40 bottles would be. Okay, those would be my top tips to solving this problem. So in your maths books, you need to write step 3 and have a go at estimating the volume of that fridge. So you can write down your workings out, write down what you think 1 bottle its volume is close to, and then have a go at all 40 bottles. And one thing to point out, really important piece of information, each cube has a volume of 10 centimetres. So these are not 1 centimetre, they are 10 centimetres cubed. So however many cubes you think it is, you'll need to multiply it by 10. Pause the video now and we can go through that together when you're ready and when you press play. Right, well done year 5. A bit more of a challenging problem. We had a few steps to follow there, but I wonder how you got on. Let's talk about it together. So here, this shape that's supposed to show the volume of this bottle of water, there are 46 cubes there. And remember, each cube represented 10 centimetres cubed. So the volume of 1 bottle is going to be 460 centimetres cubed, and you can see they've written up there. Now we know there are 40 bottles in this fridge. So we've done 460 centimetres cubed multiplied by 40. And the answer is 18,400 centimetres cubed. Now, I don't know how you've worked that one out. You might have used a written method. You might have done 460 and then multiplied it by 40 and used a written method to do it that way. You might have done 46 times 4 and then multiplied that by 100. There's different ways you could have solved that one. Okay. So the estimated volume was 18,400 centimeters cubed. Have a think about how close you were to that one. Okay, and 3B says, does this mean that all fridges have the same volume? And I've just written no. You might have written a proper explanation of that, but all fridges can't have the same volume because they are all different shapes and sizes, and volume is all about how much space that shape takes up. Well done, Year 5. You are absolute superstars. And I just want you to take a moment to reflect on how you've gotten on today with estimating volume. Do you know that volume is a measurement of three-dimensional space? Were you able to use the cubes, the pictures of the cubes, to help you estimate the volume of an object? Were you able to choose roughly the right estimation of that kind of wardrobe and the different shapes? And were you able to use that knowledge to solve problems at the end there? Do share a comment on how you've gotten on when you upload your work to Class Dojo. You might share what you've done in your book, but you might also share any other estimations you've done with objects around your house in step 2. I hope you have a fantastic day, Year 5, and I'll see you very soon.